Today I'm going to show you a method of division for one-digit and two-digit divisors called the partial quotients box model. This method is similar to what is sometimes called the Big Seven or partial quotients. It's just set up a little bit differently. Today we're going to take a look at the problem 785 divided by 4. So in this problem, 785 is my dividend and 4 is my divisor. So the first thing I'm going to do is I'm going to set up a rectangle and I'm going to divide it into sections. I'm going to start with 4 sections. I might need more than that. I might not need as many, but we'll just start with 4. And then I'm going to write my divisor 4 off to the side. So the first thing that I'm going to do is I'm going to look at the 7 in the number 785. And when 7 is in that place, it's actually equal to 700. So the first thing I'm going to think to myself is how many groups of 4 are there in 700? And I know that there are at least 100 4s in 700. So I'm going to write my 100 here, and then I'm going to multiply 4 times 100, and that gives me 400. Now what I'm going to do off here to the side is I'm going to keep track of my dividend. So I started with 785, and I've used 400 of those. So I'm going to write down 785 minus 400. And when I do that subtraction, what I see is I still have 385 that I need to divide out into groups of 4. So I'm going to use some compatible numbers here, and I'm going to think about numbers that work well together. So I know that 4 times 9 is 36. So I also know then that 4 times 90 is 360. So I'm going to write down 360. 5 minus 0 is 5, and 8 minus 6 is 2. So what that means is I still have 25 that I need to divide into groups of 4. So again, I'm going to think about what I know about my basic facts and compatible numbers, and I know that 4 times 6 is 24, and when I come over here to subtract, that leaves me with 1. Now here's where I get my answer. I'm going to add 100 plus 90 plus 6, and that gives me 196, and I have 1 left over here, which becomes my remainder. The next problem we're going to look at has a larger dividend. It is 1,015 divided by 6. So again, we're going to make our rectangle, and we're going to divide it up into some sections. I'm going to go ahead and get my subtraction problem ready over here. And I'm going to write down my divisor of 6. So again, what I'm going to start with, I'm going to look at that 1. Now, since it is in the thousands place, it is actually equal to 1,000. So I'm going to think to myself how many 6s I think there are in 1,000. And I know there's at least 100. So I'm going to write 100 down here, and then I'm going to multiply 6 times 100. And when I do that, I get the product of 600. So I'm going to come over here to my dividend, 1,015, and I'm going to subtract out 600. So when I do that, I see that I still have 415 that I need to divide into 6 groups. So what I'm going to do is I'm going to think about what I know about compatible numbers. I know that 6 times 7 is 42, so 6 times 70 would be 420, but that's too big, so I'm going to use 60 instead. So I'm going to write down 60, and I know that 6 times 6 is 36, and I have a 0 to place at the end, so that gives me 360. So when I come over to my dividend to subtract, I'm still left with 55 that I need to divide into 6 equal groups. Well, since I know my basic facts, I know that 6 times 9 is 54. And when I come to subtract, I have 1 left. And since this 1 is less than my divisor 6, I can't divide anymore, so I'm finished. So again, my quotient comes from 100 plus 60 plus 9 with the remainder of 1. For our last problem, we're going to use a 2-digit divisor, so we are going to do 1,817 divided by 12. So I know that I need to draw my rectangle and divide it into some sections. I'm going to put my divisor here, and I'm going to start my subtraction problem off in the margin. So for this particular problem, what I'm going to do is I'm going to look at that 1, and I know that the 1 is equal to 1,000. And I think what I'm actually going to do for this problem is I'm going to go ahead and move over and look at the hundreds place also. So when I see this 1 and the 8, it's actually equal to 1,800. So I know that there are 112s at least in 1,817. So then I'm going to multiply 12 times 100, and I know that 12 times 1 is 12, and I have 2 zeros to place at the end. So I'm going to come over to my subtraction problem, and I see that I have 617 left that I need to divide into 12 equal groups. So I'm going to think about my compatible numbers, and I'm going to look at my 12 and think about what can I get close to. Well, I know that 12 times 5 is 60, which means that 12 times 50 would give me 600. So I'm going to subtract my 600, and I have 17 left. Well, I know that there's only one group of 12 and 17, so I write my 1. Then I'm going to do 12 times 1, and that gives me 12. And when I subtract over here, I see that I have 5 left. Well, since 5 is less than my divisor 12, I know that I can't do any more dividing, and 5 is going to be my remainder. So to get my quotient again, I'm going to add 100 plus 50 plus 1 with the remainder of 5.